Let's see how the time permits and then we'll continue. I mean, I wanted to do isomerism. And then people, I wanted to do how hydrogen bonds are formed. A lot of you don't know how hydrogen bonds are formed. And then we want to talk about the boiling point variation, which I was talking from structure and bonding part. Structure and bonding, I told I'm doing in organic, and inorganic also I told you I'm doing it in organic. So this is the time we have it in our tute, boiling point variation. And then after that, this tute contains acidity variation, and then after that, water solubility, and then organic nomenclature, of course. Then we will that from that part we are keeping an end into our organic journey, right? From this tute we are ending organic journey, right? So next month definitely for the revision batch you have the organic day where we do conversion from morning to evening. Such a session will be definitely held before the exam. And then we will QBT number 4. QBT number 4 කියන්නේ structure is a number 4. ඒකට හම්බෙනවා next month එකේ, right? So this month we are doing the theory and the next month we are doing the questions. I mean the past papers from this isomerism. And people, organic MCQ book we are getting next month. So of course we have a lot of work. I mean a lot of questions we have next month. So kinetics also we have to do a lot of questions. So yeah, let's carry it on. Okay, now people take out your tute. The people who are new, you can have the PDF access by the link I shared, right? Tute link එකක් දාලා තියෙනවා. මේ අර උඩින් දාලා තියෙන doc file එකක් මේක open කරාට වැඩක් නැහැ. ඒක මේ fonts වලට open වෙන්නේ නැහැ. It's a Word document. And then people at the bottom I have sent you the PDF version. You can open that. හරි. So people, we have talked about reactions and we completed that. It completed. And then we talked about identifications. We completed that. Variations, we completed half, maybe 3/4, right? 3/4 completed, right? And then mechanisms we completed. Mechanisms we completed. And then now we have to talk about this isomerism. Okay, now what is this thing and from where do they ask questions? People, in the chemistry paper, you have 4 structured essay questions. First structured essay question is from general chemistry, of course, Lewis structures, resonance structures, and stuff. Second structured essay you have from inorganic. Third structured essay you have from physical chemistry. Physical chemistry means gases, kinetics, phase equilibrium, pH, solubility, anything they can ask from the third structure essay. And the fourth structure essay, we definitely know it is from organic. And people, organic, part A and part B you have to. Part A could be isomerism. And part B could be what? And people, there could also be a part C. Sometimes it changes. From time to time it changes. Most of the time you have part A and part B. Part B, you have reactions and stuff, reactions, and then maybe some identifications and stuff related to that. Mechanisms also could be there here, right? Mechanisms also could be there here. What our main focus is this one. How to answer this isomerism question. I kept isomerism to discuss at the end because there's a reason for that. This isomerism includes the knowledge of carboxylic acids, esters, the relationship in between them, and then alcohols, those, everything is important for isomerism. The reactions, the identifications, everything. For a structure essay question, you need all of them. So now we are going to start it, right? Now we're going to start it. The wait is over. A lot of students told to start isomerism as quickly as possible. So here you go as a free session for everyone. Right. Now, no need to panic, people. Just calm yourself down. Take a deep breath inside and calm yourself down. Right? Take it easy. Still, you have around 4.5 months, so no need to worry. Just work very slowly and focus on the class, right? Right. What is isomerism? Isomerism is the existence of different compounds that have the same molecular formula. In inorganic compounds, you don't have much. But in organic compounds, you have many. That means what? So let's say same molecular formula but different structural arrangement. Same molecular formula but different structural arrangement. You call them isomers. Same molecular formula. Same molecular formula. Same molecular formula, different structural arrangement. Different structural arrangement. Hurry. Then people, consider a compound like this, CH3, CH2, CH2OH. You know, this is an alcohol, right? Propanol, right? This is propanol. But people, you can change certain things. What can you change? You can change the OH location. You can put it here if you want. You can put it here if you want. It's the same molecular formula. Let's say CH3. So there are 3 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. H9 and O. So wherever you put your OH people, you are going to get the same molecular formula. But different structural arrangement. So these are called isomers. It doesn't have to be changing like this, people. It doesn't have to be changing OH. There are many isomers possible, different variations. We are going to classify them first. හරි ඉස්සෙල්ලා classify කරලා බලමු කොයි වගේ තියෙන්නේ කියලා. Right? Right. Isomers, people. Isomers first can be classified into 2 main types. Isomers can be classified into 2 main types. First on constitutional isomers. Constitutional isomers. The other one is stereoisomers. Stereoisomers. Don't worry about the names and stuff, right? Just take it as a classification. First, you have constitutional isomers. The second one, stereoisomers. Now, in the tute people, you don't have any space to draw it. So, you have the cover page. In the cover page, behind of the cover page, you can draw it here, like a classification. Right. Then people, constitutional isomers, you can divide into 3 types. Chain isomers, functional group isomers, position isomers. Position isomers. Right. Constitutional isomers are 3 types: chain isomers, functional group isomers, position isomers. Stereoisomers. Stereoisomers, people, you have diastereomers. These words, people, don't worry about them much. You will understand them later. Diastereomers. And then you have optical isomerism, or you call enantiomerism. Enantiomerism. Okay, the my classification. So what's the difference? What's the difference between constitutional and stereoisomers? People, in constitutional isomers, you are changing the location of the atoms. That means you are changing the OH. In the previous case, I told you, you're not doing this one for the first time in life. You're 2025 A-level batch, and then you have only 4 months to the exam. You have done this at least once. You know what are chain isomers, right? Chain isomers can work. You change the carbon chain. You change the atoms. You change the atom arrangement. Functional group isomers. Functional group isomers, people, are, let's say, carboxylic acid and ester are 2 functional group isomers. What? Yes. We call it like constitutional isomers. If you call structural also, it is correct. But this is the more correct one, constitutional isomers and then stereoisomers. Right. Then people, functional group isomers, ekama api karaddi balamu. Position isomers is the location. I mean, I changed the location of the OH in the previous case. You're changing the functional group from place to place. That one you call position isomers. Stereoisomers are of two types, enantiomers, and diastereomers. Enantiomers can optical isomerism. හරිද ඒවා මොනවද කියලා පස්සේ තේරුම් ගන්නේ. Now clear your mind. Draw this and clear your mind. Just draw this and clear your mind. මේක නිකන් අර classification එකක් විදිහට දුන්නේ about I'm going to tell you what are we going to learn today. That's why I gave you this, right? This is what I'm going to learn today. The theory is not hard to teach people. Theory is not hard to teach. It is about doing questions. Isomers were the questions karanda. You need to have a good idea about inorganic, about the identifications and stuff. You need to know all the possible isomers that you can draw for a compound. That is how you do an isomerism question. It's like playing chess. Isomerism is like playing chess. It's very, I mean, you have to select the correct move. Out of many moves, you have to select the correct move. So that is about selecting the correct compound in a question, right? Right. When you finish drawing, please inform. Done. Hare? Right. Now we're going to erase the board. We're going to focus on chain isomers. We're going to focus on chain isomers. And I want you to have rough papers with you. I want you to have rough papers with you, right? We're going to focus on chain isomers. Right. First, let's read the dude. Isomerism is the existence of different compounds that have the same molecular formula. Different compounds having the same molecular formula are called isomers. Isomers can be subdivided into constitutional isomers and then stereoisomers. Isomers that differ from the order in which the constituent atoms are connected to each other are called constitutional isomers. Hence, they have different structural formula. Then structural formula again, people are we are drawing on the board that thing. Right. Constitutional isomers are generally subdivided again into chain isomers, position isomers, and functional group isomers. People write there within brackets. Write there within brackets. Write there within brackets in front of that part. They are not exclusive. They are not exclusive and then can overlap. And can overlap. They are not exclusive and can overlap. Eka තේරුම් ගන්න අමාරුයි, right? I understand. I understand your feeling, right? Eka තේරුම් ගන්න ටිකක් අමාරුයි. They are not exclusive and can overlap. I'll explain that once I talk all of those three. Chain, position, and functional group. Once I discuss all of these three things, I'll discuss about that sentence. They are not exclusive and can overlap, right? Finish ready? Right. Next, the topic, chain isomers. Chain isomers. Right. Now this one. Chain isomers are those which have different hydrocarbon chains for same molecular formula. The best example now, butane, right? Butane. Meth, eth, prop, but, right? There are 4 carbon atoms. So people, I'm going to draw the simplest butane molecule. Right? Again, butane ගත්තාම අපිට ඔළුවට එන්නේ මේකනේ, right? This is butane. CH3, CH2, CH2, meth, eth, prop, but. Meth, eth, prop, but. Right. This is butane. This is butane. They're asking us to draw the chain isomers possible. Now people imagine this like 4 balls, 1, 2, 3, 4, which are connected to each other. They're like 4 balls connected to each other. Tell me how many different arrangements can you get using these 4 balls? They are identical balls, huh? They are very identical. They are very identical. How many ways can you attach them? I can take this ball and attach it here. That is one thing. This is the first one we had. This is the first one we had. So this one and this one possible. What else can you have? What else can you have? Can we have any more? Right? තව දාන්න පුළුවන්ද? මෙච්චරයිද පුළුවන් තව පුළුවන්ද? කියන්නේ මේ දෙක විතරද හදන්න පුළුවන්. මේකේ මුකුත් ඕගැනික් නැහැ බම් මේකේ ඕගැනික් නැහැ. There's no organic here. මෙතන ඕගැනික් උඹලා මුකුත් දැනගන්න ඕනේ නැහැ. It's about pattern recognition and logic. How to arrange the carbon atoms. හරි? කොයි විදිහටද දාන්න බලා. It's like you have 4 balls and I'm telling you to arrange it in different locations. Right? මේක organic නෑ. හරිද? This is only logic. Only this, right? Yeah, only 2. Good. So there are 2 then. There are 2 isomers. CH3, CH, CH3, CH3. Draw them. Draw these 2. So these are called chain isomers. You change the carbon chain. Carbon chain එක වෙනස් කරොත් ඒක chain isomer එකක්. හරිද? තාම organic මෙතන නෑ. This is not organic people. This is logic, right? This is basic grade 6 logic. You have 4 balls and you have to arrange them in different ways. And make sure 2 of them are not similar to each other. පොඩක් හරකලා බලන්න අනිත් පැත්ත හරවලා බලන්න නිකන් එක වගේද කියලා බලන්න ඕනේ, right? Second one, draw the chain isomers of pentane, right? Pentane. Meth, eth, prop, but, pent. දැන් මේ ගණන් ගන්න ඔක්කොම people, we are learning it under organic nomenclature. That is at the last of the tute. Organic nomenclature අන්තිමට කරන්නත් reason එකක් තියෙනවා people. If you just study organic nomenclature without knowing reactions, what is the use? You just learn nomenclature. I mean, like, you don't know anything about organic. You don't know what is an aldehyde. You don't know what is a ketone. Without knowing any of that, you're directly learning what? Nomenclature. They're full confused people. This is for like the theory students who are learning for the first time. But still, I thought about you as theory students and only I made the tutes. So, right. Now, pentane. Pentane කියන්නේ මේක. CH3, CH2, 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 CH3. So this is pentane, right? This is pentane. You're going to change the carbon chain. You are going to change the carbon chain. Okay? You're going to change the carbon chain. How are you going to change? How many? Now, how many balls are there? 1, 2, 3, 4, 5. 2, 3, 4, 5. Right. Tell me one. 1, 2, 3, 4, 5. Tell me which ball to remove and where to attach. You can tell 5 to 3 or 5 to 2 or you can tell like that. Right? Tell me. This is make a ආතල්ලා. Make a පට්ට ආතල් people. 5 to 3. Okay, one person said 5 to 3. I'm going to remove 5 and put to 3. 2, 3, 4. Right. I put 5 to 3, right? දැන් ඊතර numbers දාලා වැඩක් නැහැ. මේ උඩ එක විතරක් numbers දාමු, right? What else? What else? Yeah, 5 to 2. 5 to 2 possible. 5 to 2. But people, you said 5 to 3 and 5 to 2, right? You can't have both of them. Why? ඉතින් මේ උඩ මේකනේ people. This is the same thing. You're going to flip the molecule other side and just overlap. You can't have that. What now? With this structure, not the above one, with this structure, tell me where and where to attach. 1, 2, 3, 4, 5. Right. With this structure. Right. Start now. Tell me. What should I do? One to 3, yes. Very good. But now you're talking, right? You can attach 1 to 3, right? That is also an isomer. Isala දැක්කද the mistake you did? You just removed 5 and attached to 2. That is the same structure නේ. Look. Same structure. මේ දෙක එක වගේ නේ. මේක අනිත් පැත්ත හැරෙවුවා මේ වගේ. එහෙම බෑ. You can't have like that. So you can't have that. එහෙම බෑ. Right? So this is it. These are the 4 isomers possible. These are the 3 isomers possible. I mean chain isomers. මේ chain isomers. දැන් හිතන්නකෝ මේකේ අර ඔය කට්ටිය කරලා ඇතිනේ. You have done isomerism නේ. එතකොට හිතන්නකෝ මෙතන OH එකක් තියෙනවා කියලා. There's an OH group attached. What you're going to do in the exam, you're going to first draw one chain of carbon. Carbon chain එක අඳිනවා. ඒකල OH එක 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 තැන් වල set කරනවා. So this is one. What I am doing is I am drawing the carbon chain like this, and this is the first isomer. When I attach carbon, when I attach the OH to here, that is the second one. When I attach the OH to here, that's the third one. When I attach the OH to here, it's the same thing, so it doesn't make any sense. And then the next structure, OH attached to here, I draw an arrow. This is the first structure. Then if I attach the OH to here, that's the second one. If I attach the OH to here, it's the same thing. If I attach the OH to here, it's the third one. Right? If I attach the OH to here, that's the next one. Eh? So it saves you time doing like this, drawing arrows. That's what I did. That's what I understood when I did a lot of papers. එතකොට අර මේ exam එකේදී what I previously did was I'm going to draw everything. CH3, CH2, OH කිය හැමතැනම අඳිනවා, right? Everything I drew. Then I learned this one. So people, when you draw all the isomers, then they are going to give some information for you, right? Information වගේක් දෙනවනේ. Can we attach 4 to 2? මට මතක නැහැ 4 මොකක්ද කියලා. හරි. people මේ අර ඔක්කොම අඳින්න නැතුව මේ ටික මෙහෙම ඇඳලා then you read that information given in the question, right? ඔහම information ටිකක් දීලා තියෙනවානේ. ඒකෙන් you can filter it out. You can say this is not, right? This is not one of them. This is not one of them. This is not one of them. Likewise, you can filter it out easily and get your answer, right? ඒක පොඩි hack එකක්, පොඩි trick එකක්. If you are a theory student, I won't tell this people. It makes no sense because those people haven't done it. But you guys have done questions from isomerism, and this concept is not new for you. I'm just making you revise the old stuff in a better way, right? So the chain isomers of this one, I can draw CH3, CH2, CH2, CH3, CH3. One more thing, people. Exam එකේදී මෙහෙම දැම්මොත් වැරදියා. If you put like this, CH2 and then CH3, CH3, you're wrong. Definitely wrong. Because I got one time wrong. Make a miss or not. වැරදි. I can make a 2 කියලා දැම්මොත් ඒක වැරදිනේ. For isomers, yeah, it's very strict. For isomers, it's very strict. අර box එක ඇතුලේ අඳින්න තියෙන එක පට්ට strict. එතකොට මේ when it comes to conversions, they will excuse that. Conversions වලට නම් අවුලක් නැහැ people, but isomers, you have to maintain the correct discipline when you're writing the atoms. Right? Then Minsha, you said like 4 to 2, that means you're attaching this one to here, right? Again, that's the same thing. Right? That's the same thing. දැන් ඔයගොල්ලෝ එක එක ඒවා හිතන්න පුළුවන් නිකන් මෙහෙම පුළුවන්ද? Right? You might think, yeah, what about this? 1, 2, 3, 4, 5. What about this? මේක පුළුවන්ද? ඉතින් මේක අරකම තමයිනේ. It's the same thing. මේක පොඩ්ඩක් නිකන් මේක අඬ මෙහාට කරලා මේ අඬ මෙහාට කරලා බලන්නකො අරකම තමයි එන්නේ, right? It's the same thing. There is no mathematical formula to get how many structures possible. එහෙම එකක් නැහැ, right? Some people ask that. Yeah, is there a mathematical formula like how many structures can we get? එහෙම බෑ. You have to draw. Then people එහෙම ඇති university එකේ උගන්වනවා ඉතින්, but we don't have. CH3, CH3. This is the other structure. Right? This is the other structure. Then make a butane නෙමෙයි යා. මේක වෙන එකක්. ඔක name කරන විදිහක් තියෙනවානේ, right? There is a nomenclature method. Yeah, we don't take cyclic compounds. Cyclic compounds කියන්නේ people like අර ගන්න බෑ ඉතින්, right? Finished? Hurry. Finished. Right. Now take a rough work book or something, rough work sheet or something, right? You're going to draw all the possible chain isomers for this one. CH3, CH2, 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 CH3. Right. It's a big thing now. 1, 2, 3, 4, 5, 6, 7. That's heptane. This is heptane. Take a rough work sheet and draw all the possible isomers, chain isomers for this one. Chain, right? Don't draw cyclic things or anything. අර එක්කෙනෙක් cyclic අඳින්න පුළුවන්ද කියලා මේකට cyclic ඇඳාම you will have to remove 2 hydrogens, right? Then the molecular formula changes. You can't draw cyclic ones for this. Let me start, right? I'm going to start. So this is the first one. අපි කිචට උඩින් අඳිමු. Right. CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6, 7. Hurry. Okay, first look at the last one attached. I'm going to take this first, remove it, and attach it to the inner carbon. So that's CH3, CH2, 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 CH, CH3, and then this carbon, this CH3 group. I'm putting it in blue. CH3, I'm attaching it to here. CH3, right? I'm attaching it here. Then I can also attach it to here, right? This carbon. I can also attach it to this carbon. Third one. CH3, CH2, CH2, CH, CH2, CH3. So I can attach it here. CH3. Can I attach it to here, people? Yes or no? Is that a different structure if I attach it to here? Is it a different structure if I attached it to here? Yes or no? Tower structure එකක් එනවද? No, right? It's the same thing. It's the same thing. Yeah, it's the same thing. එක මේක තමයි එන්නේ. ඒතකොට ඒක ආයි ඉවරයි. ආයෙ ඔක් ගලව attach කරන්න යන්න එපා, right? It's over. It's over. Now, you are looking at the second structure and you're thinking, okay, then I will do this. I will remove this carbon and attach it to everywhere. Does it work? Does that work? If I remove this one and then attach it to everywhere, does it work? Yes or no? Does that work? No, right? It doesn't work. It's all about logic. This is not organic. This is not conversions. This is logic, right? This is logic. So how your brain works. Fourth one. I'm going to take the carbon CH3 on this side of the thing, right? I'm going to take this one and attach. I'm going to attach it to this carbon. CH3, CH, CH, CH2, CH3. Right? I'm taking this one, I guess. Let's take this one. CH3. Right? This one, I'm taking this and attaching it here, CH3. It might feel like a headache, right? After some time, it might feel like a headache, but just focus, right? Just focus. What else can you, where else can you attach this CH3? There's only one location where you can attach CH3. To the next carbon, to this one you can attach. Then that's a completely new structure. Have an ordered manner, people like this. Have an ordered manner, then you won't mess up or miss anything. The මෙච්චර ලොකු ඒවා එන්න exam එකට. ඒ කියන්නේ carbon 7ක් එන්නේ නැහැ. ඒක ගොඩක් වෙලා යනවා, right? It's going to take so much time. Imagine if there was an OH also here attached. ඒක පට්ට වෙලා යනවා. ඒක හින්දා එහෙම ඒවා දෙන්නේ නැහැ. So this is just for practice. CH3, CH2, CH, CH, CH3, CH3, and then here. Right, this is the next structure. Right, this is the next structure. There's one more structure. තව එකක් තියෙනවද? නැහැ. ආයේ නැහැ. ආයේ එකක් තියෙනවද? නැහැ. Right, there is no more structures. Yes, middle CH2. Right. Right. Now you have removed 2 carbons and attached it everywhere. Now people, I'm going to remove the 3rd carbon atom. I'm going to take, that make it very confusing. This very little bit confusing. You can do one more thing. You can do one more thing. What you can do? I can attach this CH3 to this carbon where it is already attached to CH3. එතනින් එකක් එනවානේ. Right? දැන් මේක පිස්සු වෙදෙනවට ටිකක් වෙලා ගියාම 6th one CH3 CH2 CH2 C CH3 CH3 CH3. Right. මෙහෙම එකක් එනවා. That's the 6th one. Right? That's the 6th one. Hold on. Hold on. තව තියෙනවා. Right? තව තියෙනවා. 7th one. I don't know how many we can draw. Maybe 20 or something we can draw. I won't draw that much. හරි ඔක්කොම අඳින්නේ නැහැ. බලමු. Let's see. How many? Right now you can remove this carbon maybe. I'm going to remove this CH3 group and attach it here. So that's going to be CH3, CH, CH, C, CH3, CH3, CH3. And then that's going to take time now, right? තව පුළුවන් people. තව පුළුවන් වෙන්න ඕනේ දැන් මේක නෑනේ. 1 2 3 4 5 6 7. මේක නෙන්න. හරි. තව පුළුවන්ද? We can draw more, right? How many did you get? You guys, how many did you get? Wait. One minute. Right. 9ක් එන්න ඕනේ people. There should be 9. Let's see. Let's see what we can take. I changed to Wi-Fi. Can you see? Can you see the board? Right. හතක් පුළුවන්. හතක් නේ 9ක් පුළුවන් people. 9. Right. Now I can also put the CH3 here නේ. 8. CH3 C CH3 C CH3 CH CH3 CH3 and CH3. මේ හා පැත්තේ එකමත් තියෙන්නේ. ඕනේ. It's the same thing. It is a top thing, right? We have to just turn it. If you turn it 180 degrees, it is the same thing. You can't take that. 1, 2, 3. Okay, first this one, then you remove this carbon, 1, 2, that's all. And then you remove this carbon, you attach it here. You can attach it here, you can attach it there. Right, 1, 2, 3, that's all. Then you're gonna remove the next carbon, CH3. And if you're gonna attach it here, okay, yeah, another one, guys. Both CH3 on the same carbon at the center of the sixth structure. Sixth එකේ yes නේ. එහෙම එකක් ගන්න පුළුවන්. මෙහෙම එකක් ගන්න පුළුවන්. You can put both the carbons here. එහෙම හිතුවොත් හරිනේ. CH3 CH2 C CH3 CH3 CH2 CH3 right. ඔහොම එකක් එනවා. 9th one තව එකක් එන්න ඕනේ. තව එකක් කොහෙන් හරි එන්න ඕනේ. right. මේ 9th one එක මං දාන්න යන්නේ නැහැ. ඔක හොයන්න ගියොත් වෙලා යනවා right. It's going to take time. Right. There's a 9th one. කොහොම හරි 7ක් එන්න ඕනේ people. ඔය මොනවා කරලත් කොහොම හරි 7ක් එන්න ඕනේ ඕක. පස්සේ වෙලාවක හිතලා බලන්න අනිත් ස්ට්‍රක්චර් එක මොකක්ද කියලා. It might take some time for you to find it. Not gonna waste my time, right? එතකොට exam එකේ people, you won't get this much of carbon atoms. You are gonna get maybe maximum 4 or 5. 5 ended now, maximum 4. Maximum 4 or 5, maybe, yeah, 5. Right? නමයයිනේ people. නමයයි එන්නේ. ඒතකොට 9ක් කියලා තමයි දාන්න ඕනේ. exam එක MCQ එකට අහන්න පුළුවන් හැබැයි. MCQ එකට අහන්න පුළුවන් how many isomers are possible for heptane. එහෙම අහුවොත් එහෙම ඉතින් මේ ටික ඔක්කොම අඳින්න ඕනේ. So it's going to take time, right? It's going to take time. Right. Okay then people, yeah. Now go to position isomers. Now go to position isomers. Now go to position isomers. Position isomers. හරි. Initial structure එකත් එක්ක තමයි 9ක් එන්නේ. Initial structure එකත් එක්ක තමයි 9ක් එන්නේ. ඒ කියන්නේ ඒකත් isomer එකක්නේ. That is also one isomer. It's raining heavily, people, here. Okay. Position isomers are those which have the same functional group or substituents in different positions in the same carbon chain. ඒ කියන්නේ functional group එක people. 10ක් ආව නම් people මේ අර ඒකේ එකක් repeat වෙන්න ඇති පොඩ්ඩක් බලන්න. Just forget about that heptane thing. Now focus on this one. People, you have, let's say, CH3, CH2, CH2OH. People, in this carbon chain, this OH is the functional group. I see. This OH is the functional group. This is the functional group people. You can change the location. මෙයාගේ location එක මෙතෙන්ට දාන්න පුළුවන් නේ. මෙහෙම. So that is also an isomer. This is also an isomer. Right? This is also an isomer. Also, yeah, that's all. Eh? Yeah, that's all. So these are the two possible isomers for this compound, right? For this compound, these are the two possible isomers. එතකොට අර functional group එකේ location එක මාරු කරොත් you're getting another structure. Right? You're getting another structure. Right. So, look, you don't change the chain, but you change the position of the functional group. That is what you do. Draw the position isomers of the following compound. Right. First one, let's say this compound. Draw the position isomers of CH3, CH2, 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 Br. Don't change the carbon chain. Don't change the carbon chain. Draw position isomers for this. There's only one, I guess. There is only one. Draw position isomers for this one. එකයි දෙන්නේ. කියන්නේ මේකත් එක්ක එකයි. ඒකල්ල people put this as the first one. And on the next page you have the next one. Second එකට මේක දාගන්න. CH3 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 this one. Draw the position isomers for this one. Make it a decaying the people, you can attach the Br to this place. So you get CH3, CH2, CH, CH3, and then Br. Or Gandabula. Right? What about this one? How many how many position isomers are possible for the second one? How many position isomers are possible for the second one? Three, 4. Others? How much? Two. Interesting. 4. 4. Let's see. So this is the first structure. Then people, you can attach the Br to this place. You can attach the Br to this place. That's the second one. After that, now you don't change the carbon chain. No? Carbon chain I told you not to change the carbon chain. So Br can go here. Right? So this original structure is the first one. This Br, if you put it to here, then you have the second one. What else can you do? You can put the Br to here, right? You can put the Br to there. If you put the Br to there, that's the third one. So how much? Yeah, 2 more. 2 nai pulang, only 3, right? Yes. Only 3 possible. එතකොට මේ arrows අඳින පුරුදු වෙන්න, right? When you're drawing functional isomers, don't go on writing everything. Don't go drawing everything. Learn to use these arrows. මේ arrows වලින් ගන්න. So this is the first structure, this is the second one, this is the third one. So if in the isomerism question, if they say, okay, this is a compound which is a primary, what? It's a primary alkyl halide. Hurry. No, can't change CH3, I told you. CH3 වෙනස් කරන්න බෑ. So people, if the question said it's a primary alkyl halide, if it's a primary alkyl halide, people, then you can directly forget about the second one. So you cross it like this. Why? This is a primary one. The first one is a primary. The third one is also a primary. And you do questions, right? That is how you do isomerism questions. So how many is possible? 3 are possible. Right? How many are possible? 3 are possible. Learn to use arrows. People, you can do very quickly isomerism questions. And also we will use that thing now. When you are doing the fourth structure, they say don't do the isomerism first. Do the part B. Part B එක ඉවර කරන්න. Then look at the time. How much time do you have remaining? Let's say from 15 minutes, I told you to keep for the fourth structure, they say, or anything. All structure is 15 minutes. ඒක තිබ්බට පස්සේ you look at the time and then you see, okay, now 10 minutes left. So you have only 10 minutes to find all the structures. හරිද? විනාඩි 10යි තියෙන්නේ මොනව කරන්නත්. හරිද? So what I recommend is first do part B. Then go to the isomerism question. Then try it for 10 minutes. If you still didn't get it, then leave it and go to the essay. Do not wait on it. 2024 paper, that thing happened for many people. Isomerism question is difficult. It is the most difficult question in the past 5 years. Maybe 6 years. හරිද? එතකොට මේ ඒකේ එල්ලිලා හිටිය කට්ටිය. හරිද? උන් ඔක්කොම fourth structure essay එකේ එල්ලිලා හිටියා. What happened is the essay was quite easy. essay එක බට්ට ලේසි. ඒකෙන් මුකුත් නැති වුණා, right? So අන්තිමට organic එකත් වැරදි. essay එකත් කරන්න බැරි වුණා. So that's the thing. That is why some people got B for chemistry. Some of my friends. අපරාධ ඉතින්, right? They wrote the MCQ well. essay එක අරම වෙලා. So writing papers is important. Timing papers is important. It's not about just hanging on to one question and finishing that question. It's about leave and moving forward. That's what's important. Hurry people. Next one, functional group isomers. Functional group isomers kiyanne, for example, this one. The first one, aldehyde ketone. Hurry, look at you. They are also same. CH3, CH2, C double bond oxygen, hydrogen. Look, what's the molecular formula? C3H3456. C3H6O, right? C3H6O. Other one possible, CH3, C double bond oxygen, CH3. So that is also C3H6O. So these are also two isomers of each other. The only difference is people the exam එකට මේක එනවා. Definitely aldehyde ketone is coming for the exam. හරිද? මේ වගේ isomers එනවා. People the thing is, imagine it like this. It is not an aldehyde, not a ketone. එහෙම හිතන්න එපා. Think it like this. The carbon double bond oxygen, this part is moving here and there. This part is moving here and there. That's all you have to remember. අර aldehyde ketone කියලා compounds දෙකක් විදියට හිතද්දී ඕක අමාරුයි. It's going to get hard for you. What I recommend is just imagine like carbon double bond oxygen. අන්න ඒ විදියට හිතන්න. එතකොට පට්ට ලේසි වැඩේ, right? It's very easy after that. So this is the first one, aldehyde ketone. Draw it. This is the aldehyde ketone. Right? This is an aldehyde, that's a ketone. It is an aldehyde. And the other one, it's a ketone. It's a ketone. Right. Then people, next one. Second one, alcohol and ether. Alcohol and ether. ඕගනන් එන්න people, in the exam you won't get alcohol and ether, but still you can write it. They are also having same molecular formula, different structural arrangement. Second one, alcohol and ether. So alcohol, CH3CH2OH. CH3CH2OH. and then either CH3 or CH3, right? So this one also C2H3456, C2H6O. This one also C2H6O, C2H6O. That's also C2H6O. Next one, carboxylic acid ester. Carboxylic acid ester. මේකත් එන chance එක අඩුයි. There's a less chance of coming. Carboxylic acid ester, third one. Carboxylic acid ester. So CH3, CH2, C double bond oxygen, OH. The මේක අර aldehyde එක වගේ හිතන්න අමාරුයි, right? This one is just a little bit hard to think like that. However, you can just look at this like this. CH3, C double bond oxygen, oxygen, CH3. මේක එන්න තියෙන chance එක පට්ට අඩුයි for the exam, but we can't eliminate it. Things can change in the exam, right? Things can change in the exam. So this carbon amount 1, 2, 3, C3, H 1, 2, 3, 4, 5, 6, H6, and then oxygen 2, right? 2 oxygens. And this one, C3, H6O2, same thing, right? Carboxylic acid ester. No, you can't consider that. සමහර වෙලාවට people, if it was more than this chain CH3, CH2, 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 CH3, එතකොට අර ලොකු group එකක් එහා පැත්තෙන් attach කරන්න ඕනේ. ඒකට එහෙම හිතන්න බෑ ඉතින්. හරි. Then fourth one, alkyne diene. දැන් ඕක එන්නෙම නෑ people. For sure it is not coming to the exam. එන්නෙම නෑ. හරිද? මේක නිකන් දෙන්නේ. ඕක නම් එන්නේ නෑ ඉතින්. දැන් ආවොත් වගේ දැනගන්නවා වගේ then in vain if it came, just to know, right? Alkyne diene. Diene කියන්නේ මොකද්ද? CH3C triple bond carbon CH3. So this one you can make it like this: CH2, CH, CH, CH2. This one. So this is alkyne and that's a diene. C4, 1, 2, 3, 4, H, 1, 2, 3, 4, 5, 6. C4, H6. Diene නම් එන්නේ for sure people. ඒක නම් එන්න chance එක ඉතින් very less ඉතින්, right? First one එනවා. First one is there of course. But the second one and third one and fourth one, not much thing, right? We can't expect it like that. So, anyone who wants to cover organic people who didn't join my classes or something, you can go with that group class thing. Right? ඒක අර සතියෙන් සතිය පොඩ්ඩක් අර ටික slowly covering the full organic I'm doing, just like a theory class. Not like in the revision, I'm not doing it like the revision, I'm doing it like normal theory class. So it will take around 2 months probably. Okay. Then read that part. We do not see much commonly the functional group isomers. First two are there in majority of questions. First two නෙමෙයි first one actually. First two. දීත නම් එන්නේ නැහැ මම දැකලා නැහැ. However, you cannot ignore the third one and fourth one as well. එතන numbers වල පොඩි අවුලක් තියෙනවා. හරි. හරි. දැන් ඕක තමයි මේ scene එක. What I'm going to give you a question now. Take a rough worksheet or something. Take a rough worksheet or something. So there is a compound, people. There is a compound. So that compound contains carbon atoms, 4 carbon atoms, right? There are 4 carbon atoms. The amount of hydrogen, 2, 3, 4, 5, 6, 7, 8. And 1 oxygen. C4H8O. So there are some details given about these isomers, right? There are some details given about these isomers. It is reacting with PCC. It is reacting with PCC. PCC නෙමෙයි මොකක්ද? Sorry. නෑ, එහෙම ගන්න බෑ. AgNO3 ammonia. Ammonical silver nitrate to give silver mirror. Then දන්නවා මොකක්ද කියලා, right? Right. So this is the information given, people. Now you have to tell me what are the possible isomers for this compound, right? What are the possible isomers for this compound? What are the possible isomers for this compound? Identify the compound and then draw all the possible isomers. Change the chain and then everything you can do and see. But don't make it a ketone. Why? It should react with ammonical silver nitrate. It should react with ammonical silver nitrate. So don't make it a ketone. How many? People, how many? Tell me, come on, quickly. Are you still doing? 2. 2. Yes, let's see. So C4H8O, that means 1, 2, 3, and 4 carbons, right? This is the first structure. Then people, if you attach the aldehyde carbon to this side, doesn't make any change. It doesn't make any change, right? It doesn't make any change. It's the same thing. So what I'm going to do is I'm going to change the carbon chain. I'm going to remove this CH3 and I'm going to attach it here, right? I'm going to attach it there. So you're getting CH3, CH2, CH, C double bond oxygen, hydrogen. And then you are getting CH3. Now you can draw another 2. You can put this, now there's only another one. You can draw it, you can put it here. Right, you can put it there. So if you put it there, then you're going to get, right? You're going to get CH2, CH, CH3, CH3. Right. There are 3 possible isomers. 1, 2, 3. Second එක පහක් දාලාද? හරි. එතකොට හරි. Okay. එහෙම තමයි people dumb වෙනවා doom වෙනවා right. Now okay. So only two possible. You are correct. Only two possible. Only two possible. Hurry. That's it. Next question. Next question. Next question. C5. 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, 5. C5H10O. C5H10O. Then I'm going to tell you it is going to react with Lucas reagent. Lucas reagent is going to react to give instant turbidity. It is giving instant turbidity. Now pick up the isomers and then tell me what are the possible isomers. World War 3 delayed until GTA 6. Yes, probably. GTA 6 ගහන්න බෑ හරිය. If you have a very good computer, 14 gen computer, you can play GTA 6. Otherwise, it's going to be an issue. Yes, it's a tertiary alcohol then. How much? Only one loop. Hello? CH3, CH3, CH3. It should be a tertiary one, right? It should be a tertiary one to give an instant turbidity with Lucas reagent. Then that means OH should attach here. Then the remaining carbon, I mean, I'm attaching it here, right? So those are the only two possible things. Those are the only two possible things that's the only possible isomer which you can get. Okay? That's the only possible isomer which you can get. Right, that is correct. Right, that is okay. Next one. Yes, only one. Next one. Okay. I'm going to increase the difficulty little by little. C6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I'll give something like before. C6H11Br. C6H11Br. So this undergoes unimolecular nucleophilic substitution. Can you remember? Who will undergo unimolecular nucleophilic substitution? Primary or secondary and tertiary? Bimolecular, ne? Unimolecular, bimolecular. No, unimolecular. 1, SN1. Unimolecular substitution reaction, it is happening for secondary and tertiary, right? Unimolecular is secondary and tertiary. Secondary and tertiary, not primary. දැන් මෙහෙමනේ. ඒක kinetics වල තමයි ඉගෙන ගන්නෙ. අර දන්න කට්ටියට මම කියන්නම් for the people who knows kinetics. Let's say yeah, SN1 කියමුකෝ. So CH3 CH2 Br plus OH minus. People, in this compound, you cannot form a carbocation, right? You cannot form a carbocation. So directly this reaction will happen. Directly this reaction will happen. CH3, CH2, OH plus Br minus. People, in the rate equation, you have two molecules, right? You have two molecules. So therefore, this is called bimolecular. Bimolecular substitution. මේක අර මේ දන්නේ නැති කට්ටිය අහන්න එපා, right? For the people who knows kinetics, I'm telling, who knows a little bit of kinetics at least, right? Bimolecular substitution is this one. In the rate equation, there you can see two molecules. But people may, when it comes to tertiary and secondary, මෙහෙමනේ CH3C CH3 CH3 Br. When it comes to tertiary and secondary, first what happens is this will go to Br minus and the carbocation is forming, right? And the carbocation is forming like that. Then what happens is the substitution, right? CH3C plus CH3 CH3 OH minus. Then you get that compound CH3C CH3 CH3 OH plus Br minus. So the RDS, the rate determining step. The rate determining step is this one. The RDS is this one. So you write the rate equation for RDS. මේ දන්නේ නැති කට්ටිය නිකන් ග්‍රීක් වගේ ඇති පොට්ටක් නිකන් අහන්න නැතුව ඉන්න. Look away people. Oh, close your ears and say like අර පොඩි කාලේ you close your ears and la 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 you shout. අන්න එහෙම කරන්න. Don't even hear this if you don't know kinetics, because we are doing kinetics and we didn't complete this part yet in the class. So don't worry about this one. So this is the RDS, the rate determining step. In the rate determining step only you write the rate law. R equal K, this damn thing I'm going to put it as M to the power something, right? So this is 1. So you can consider RDS, right? RDS, the elementary step. It's an elementary step. There were reactions which contain more than 2 steps or 3 steps maybe. Those reactions, each step is an elementary reaction. It's an elementary reaction. Because of that you can predict the order, right? Because of that you can predict the order. So the order is 1. So that means this is a unimolecular substitution reaction, right? So that's a unimolecular substitution reaction. Probably, yeah, right? Okay. So that's the thing. So that is how you check whether it's unimolecular or bimolecular. All right. Now, people, this is SN2. SN1 name SN2. SN2. So it undergoes nucleophilic substitution bimolecular. Bimolecular ones with OH. OH minus. That means, people, this should be definitely primary, right? Only primary compounds you have to take. Only primary compounds you have to take. Okay? You have to take only the primary compounds. Do it quickly. Taggala grande. Next question, I will give you a more tougher one than this. I'll give a tougher one than this. So people who want to join the revision, you can drop me a message to this number. The revision and the shadow papers you have, I told you everything about shadow papers in the special meeting as well as the, what you call, as a video I put it. So there's a group, Telegram group also about the shadow papers. If you are in Kandy, you're lucky, you can come and write the papers physically at Faraday on Friday, and most probably I'm trying to get a date on Monday. Not sure whether, let's see, will you? Right, Friday and Monday most probably. So that's the number. You can drop me a message if you want to join the revision. Next month, we are doing the phase equilibrium Raoult's law part. Phase equilibrium Raoult's law part. And then kinetics question practice. Kinetics question practice. And then isomerism and all questions. Isomerism plus organic. So these things we'll be doing in the next month. So this one is Raoult's law, right? Raoult's law and the graphs and everything, which is like jumbled and jumbled. So you can join with us. Right. 7 isomers law. Let's see. 7 isomers law. Let's see. Others, what about others? Got others? Seven. Okay, now I'm going to draw. So let's draw, will you? So C6H11Br. CH3, CH2, 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 CH2Br. 1, 2, 3, 4, 5. Another one. CH3. So that's 1, 2, 3, 4, 5, 6. So you have to select only the primary alkyl halides, right? You have to select only primary alkyl halides. So this is bimolecular, so that means you are selecting only primary. So this is 1, right? This is 1. And the second one, you can put the BR. No, you can't put the BR there. Why? It's the same thing. So this is the only possible structure for this chain. Then you can change the chain. Chain what the we're going to put CH3, CH, CH3, CH2, 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 BR. 1, 2, 3, 4, 5, 6. Right. Now, this is the second structure. Second one. Also, you can put the BR here. That's the third one. That's the third one. Then I'm going to attach the CH3 to the central carbon. The CH3, CH2, CH, CH2, CH2, BR. Right. Now I'm going to attach the BR. Now this is the fourth one. This is the fourth structure. This main structure is the fourth structure. I'm going to put the BR to here, right? That's the fifth one. That's the fifth one, right? That's the fifth one. Then the next one I can do, I can put the CH3 to here. CH3, CH2, CH2, CH, CH2, BR. So I can put this is the sixth one. This is the sixth one. I can put the bromine here. I can put the bromine here. Also, I can put the bromine there. I can put the bromine there. That's a different one. That's a different one. Right? That's a different one. No, right? That's not a different one. That is repeated. That is not a repeated. That's not a one. That's repeated. Here's this one. This is there. Then I can put the CH3 here, right? I can put the CH3 there. Then that's also gonna be a structured. No, that's not gonna be a structure. So altogether 7 structures possible. So these are the only structures which I can draw. Could you please help me? You can draw another one, right? CH3, CH2, CH3, CH3. 1, 2, 3, 4, 5, 6. Make කලින් ගත්තද? නෑනේ. I didn't take that, right? Did I take that? Did I take that? I didn't take this. අර කලින් එක වගේ වෙනවා දැන් ඈ. දැන් කීයක් එයිද දන්නේ නැහැ. Right? Okay. Then it's better if I put C5 නේද? C5 දැම්ම නම් කිසි කරදරයක් නැහැ. Only 5 carbons නේ. Hereafter I won't put 6 carbons. එපා වෙනවා වැඩි. හොයන්න ගියාම එපා වෙනවා. So BR I'm going to yeah, that's the structure. So that's the structure possible. And also I can put it here, so that's going to be a secondary. I can put it here, right? This is the 8th one, this is the 9th one. ඔහොම කීයක් එයිද දන්නේ නැහැ people. I'm going to stop this now. Number of hydrogen atoms are going to remain the constant. Even though we change the carbon chain, it's not going to change. I should have put 5 people here. Make sure 2 isomers are not equal to each other, right? Make sure 2 isomers 6 and 7 same. Yes, 6 and 7 is same. Yeah. Take a back. 7, 8. Tava hambunat people draw it. I'm not going to take much time into this. Right. Now I'm going to erase the board. Hereafter I won't put that amount of carbon. Right? Okay. Right, now next one, I'm going to give some reactions together with it. So, 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 2, 3. C3, 9. C9, H. Hang on. 1, 2, 3, 4. I have to create the question. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 and H10 and O. Right. So this is compound A. Compound A reacts with lithium aluminium hydride and dry ether. Compound A can react with lithium aluminium hydride dry ether, right? And it forms compound B. Compound B, people, it does not give an observation to Lucas. It never gives an observation, not within 5 minutes, not within like yeah, there are 30. Forget about the previous one. I didn't tell the question yet. Lucas එක දැම්මහම instant turbidity. Yeah, instant turbidity. Right, instant turbidity you get. Find A. It's gonna be hard. This is hard. I'm gonna give one more hint. I'm going to tell you this one is going to react with the failing solution. It's going to react with failing. Compound A will react with failings. It's going to react with failing solution to give a red-brown color precipitate. Right. Find it. Find A and find B. So this is how a structured essay is created, people. Yes, there are 9 carbons in the structure. You won't think it even. I know you won't even think it. You will never think because you haven't done enough questions, maybe. The people who have done questions, they will see it. Try Galavan. Right? Try and see. Because the first time I faced this, I kept doing for like 2 hours. I kept like creating for 2 hours. And I gave up. Eventually, I gave up. Next day, sir said it. Right? What could possibly be this structure, right? C9H10. Podain. 1, 2. Wait, make a C8 කරගන්න. C9 නෙමෙයි C8. C8. එතකොට 5, 6, 7, 8 නේ. 5, 6, 7, 8. Yeah. C8H8O. C8H8O. Yeah, now do it. C8H8O. Yeah, that's it. C8H8O. One, two, three, 4, 5, 6, 7. It's sorry guys. Don't hit me. C8H7. Hari. ඔක්කොම හරි. Now do it. If you are swearing at me, please don't. Right? C8H7O. C8H7O. Hari. Now do it. Come on, guys. It's just a mistake. Of course, Fawaz, you're correct. One person cracked the code. No. So 1, 2, 3, 4, 5, 6, 7, 8. Harish. Right. Okay. Last time I'm going to change, right? Last time. Okay. Done. Okay. Right? Okay. Last time I was going to change it. Right? This is all. It's hard to create questions, you know. If it's hard for you to think this question, it's hard to create the question within a live class. I didn't prepare for it. Not H9, H8. H8. That's all. Now okay. Everything is okay. Tiumal, did you find? Atal ne? Isomerism is Atal now. This is nice. I like this part, actually. Good. Propinol. It's C8. Huh? Yeah, no, it shouldn't be like that. Like an instant ability. හිතලා බලන්න තව ටිකක්. I think I messed up this. Okay, I'm going to do this question. Look, what I wanted to do was, this is the only thing which I wanted to do. I wanted to create this compound. C6H5. ඔතන මේ බෙන්සින් එකක් තියෙනවා. හරිද? මට ඕනේ උනේ instant ability එකට මේක දාන්න. Now forget about stop doing the question. What I wanted was this. හරිද? මේක තමයි ඕනේ උනේ මට. Right? මේක reduce කරනවා. මෙතන එක carbon එකයි එන්නේ. ඒතකොට මේක C7 වෙනවා. It's hard to create questions within live class. Next day I'll send that thing like after class. After the class, I send you a PDF. I'll send some questions like this. CH2OH. මෙයා instant turbidity දෙනවා නේද? මෙතන C7 එන්න ඕනේ. එතකොට වැඩේ හරි. මෙයා instant turbidity දෙනවා නේද? Do you remember? This guy gives instant turbidity. This was my idea, right? This was my idea. Question එක නෑ මට. Make this was my idea. Do you get it? This gives instant turbidity, right? This gives instant turbidity, right? Yes. And one more thing I messed up. This one. Benzaldehyde doesn't react with failings. Yeah. So මෙතන දෙන්න ඕනේ මේක. මොකද්ද? මොකද්ද මෙතන දෙන්න ඕනේ? Silver nitrate ammonia. ඔන්න ඕක තමයි දෙන්න ඕනේ, right? ඒතකොට වැඩේ හරි, right? So, you know, to create this question, you have to think many things. First thing, you need to know that this guy gives instant turbidity. So that is going to be a question. In your paper, it might be a question. Second one, this is the first one, this is the first one. Second one, you need to know this compound, benzaldehyde, doesn't react with failings. Right? මාර හිතන් හිටියේ මෙතන තව කාබන් එකක් දාලා එතන විකාරයක් වුණානේ. ඒකයි. Right. That's the second one. Benzaldehyde doesn't react with failing solution. Third one, you need to crack it down. You have to know that there's a benzene inside this. Having 7 carbons is impossible in a question like that. So there is a benzene ring definitely. ඒක දැනගෙන ඉන්න ඕනේ. So, and these reactions you should know. ඒක නම් මහ ලොකු දෙයක් නෙමෙයිනේ. This reaction, this reaction you should know. That's all. Right? That's all. Right. Sorry about messing it up. Right? Sorry about messing it up. Yeah. Let's move on now. Stereoisomerism. Stereoisomers. මම මේ වගේ similar questions ටිකක් දෙන්නම් after the class, so you can do them. You can chill out. Right? If you have any issues, drop it in the family RChem group. Somebody might help you out. Right. එතකොට next one, stereoisomers. Stereoisomers. Hari. This is the most important one. Lot of you have problems with this, right? Lot of you have problems with this. Stereoisomers. Okay, first of all, you need to understand some word. Oops. You need to understand one word. What is වචනයක් අඳුරගන්න ඕනේ? Superimposing. No, what I wanted to show was that Afranas, the thing is like it forms instant turbidity. එතකොට එතන identifications වල under Lucas reagent I gave it as a special concept. Yes. Right. Superimposing. I want you to keep your hands in front of your face like this. Like this. Keep your hands like this. Now, try to bring them on top of each other. Can you overlap them like this? මෙහෙම පුළුවන් කියන්න එපා. I'm telling like this. Can you overlap them? Can you overlap them? See, you can't, right? You can't do that. You can't do that. When you look into the mirror, you look into the mirror. දැන් මෙහෙමනේ තියෙන්නේ. හරි මෙහෙම තියාගත්තා කියමුකෝ. You look into the mirror and then you see the opposite of your hand, right? Those two images are non-superimposable. Superimposing කියන්නේ මොකද්ද? Superimposing කියන්නේ people you can keep one on top of each other like this. මෙහෙම. Like this. This is superimposable. This is not superimposable. This is not superimposable, right? You can't superimpose them on top of each. That is what you're telling. We need to understand some words before learning stereoisomers. Superimposing. Keep your hands facing palm up. Now overlap them. They cannot be superimposed on each other. However, your finger arrangement in the hand didn't change. Right? You didn't remove your fingers or anything, right? Your ring finger, your pinky finger, and all are still together. Your thumb is next to index. It's just the other side. See? Everything is same. Everything is similar. This finger, all are similar, right? Unless you have wound or somewhere. It is same, right? It is same. But you can't overlap them. See? You can't overlap them. You can't overlap them. This is known as non-superimposable. Right? This is known as non-superimpossibles. Right. Now we are going into stereoisomers. Stereoisomers can be subdivided into two types, as I said before, diastereomers and then enantiomers. First, we are going to learn about diastereomers. People, diastereomers, there are many. I mean, more than one. Diastereomers, there are many. But in our syllabus, diastereomers. Right? Among them, in our syllabus, we talk about geometric isomerism. අපි කතා කරන්නේ මෙන්න මේක. Geometric කිව්වහම what we have is cis trans isomerism. Cis trans isomerism. That is what we have. This is what we have. Cis trans isomerism. Others we don't talk about. We don't talk about them. We talk about geometric isomerism, and under that we have cis trans isomerism. Right? Look. There are different types of diastereomers, but within our syllabus, we learn only geometric isomers, or you call it cis-trans isomers. The conditions to have a diastereomer, right? There are some conditions you should fulfill in order to make a diastereomer. First one, in order to have a diastereomer, in order to have a geometric isomer, right? In order to have a geometric isomer. Diastereomers, people, there are many types. So this is just one of them. Correct that. The conditions to have a geometric isomer. The conditions to have geometric isomerism kiwathari. Right. The first one, under first one, right? Presence of carbon-carbon double bond. 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 Second one, two groups attached to carbon, two groups attached to one carbon should not be identical. The two groups attached to one carbon atom should not be identical. I'm talking about that carbon-carbon double bond carbons. A carbons two groups attached to carbon should not be identical. You'll understand what I told. Now, look. This is what a geometric isomer looks like. C double bond is there. Okay. And then people, there are groups attached to this carbon and this carbon and this carbon and this carbon. The only thing which should be fulfilled is that this group should be different from this one. Let's say A, and this should be B, not A. It should be A and this should be B. It's okay if this is A and this is B or anything else. Or anything else except A. Right? Do you understand what I'm telling? Again, this thing happens. Do you understand what I'm telling? It should be B or anything else except A. So, hydrogen end CH3 end CH2 CH3 end, right? It could be a chlorine, it could be a bromine, whatever. The only thing is it should not be equal to this one. Did you get it? It should not be equal to this one. That's the only thing which you need to fulfill. That's the only thing which you need to fulfill. If these two groups are same, That means it will not show isomerism, geometric isomerism. These are not geometric isomers, right? These are not, this is not a geometric isomer. Because why? This group and this group are same, right? That group and that group are same. There are no geometric isomers for this compound. Right, now I'm going to draw an example now. I'm going to draw an example for you to write in the tut. Draw this. Carbon CH3H CH3H. Right. This is a geometric isomer. So now what you can do is now you can remove the CH3 and attach here. Hydrogen you can attach here. So this is a geometric isomer of the previous case. When you have the two similar groups like this, you call this cis. And this one, when you have it in a diagonal like this, you call that trans. This is the trans isomer. This is the cis isomer. That's the trans isomer. This is the cis isomer. Did you understand this? Yes or no? Did you understand this? Yes. Hari. Then people, after drawing this, let me know. After drawing this, let me know. Done, ne Hari. Now, identify whether the following are geometric isomers or not, right? You have to identify whether they are geometric isomers or not. The only thing which you have to look is either one of the carbons are same or not. That's all. CH3, this is the first one. CH3, CH2, CH3, hydrogen, chlorine. Is this a geometric isomer? Can we make a geometric isomer out of this? Yes or no? It's a chlorine. Can we make a geometric isomer out of this? Yes or no? Everyone. Yes or no? Yes, it's a yes. Not a no, name yes. Why? All you need is two groups that are different to each other. You can see this is different to this. Okay. This is different to this. Okay. That's all. HRI, right? This can be used as a geometric isomer. It can be taken. Second one. Draw it very small, people. Put it on the inner. Carbon, double bond carbon, hydrogen, CH3, CH3, bromine. What about this one? Geometric isomer or not? Geometric isomer or not? Yes, 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 yes. Yes, yes, yes. Hari. It's a geometric isomer. Okay. What about this one? Third one. What about this one? Does this show geometric isomerism? No. Why no? Why is it a no? Yes, it's the left side same. Nay, I just fooled you. Right, everyone is getting fooled. Some people tells no. That's good. Yes, same group on the same side. Yeah, this cannot have geometric isomerism. Last one, fourth one. C double bond carbon benzene. This one. What is wrong with this camera sudden all of a sudden? Can you tell me that fourth one? We can have, right? Yes, we can have. Right. Draw these four. And once you're finished, please inform me. Done, ne? Hare. Then we will write there below this. You have to write two statements. You have to write two statements. You have to write two statements under that. Yeah, it's like the app is shutting down quickly. Sometimes it happens. So it goes to that plus sign. It was hibernating maybe like in the past weeks we didn't have it, right? Suddenly now you have it. Like it stayed under hibernation and suddenly it came out, right? Now we will write those two statements below geometric isomerism. යට කොයි හරි ඉඩ තියෙනවා ටියුට් එක යට හරි වගේ මෙතන කොහේ හරි ලියන්න. Geometric isomers cannot be superimposed on each other. Cannot be superimposed on each other. Yes. Chemistry is killing the camera. Yes, of course. Right. Yeah. Geometric isomers cannot be superimposed on each other. Geometric isomers cannot be superimposed on each other. Geometric isomers cannot be superimposed on each other. Right? Huh. Next one. They cannot interconvert between each other. They cannot interconvert in between each other. They cannot interconvert in between each other. They cannot interconvert between each other. They cannot interconvert between each other. Again, people, the best example is again due to pi bond. Due to pi bond. They cannot interconvert between each other due to the pi bond. Best example is consider two test tubes. In this one, you have natural rubber. Natural rubber. And on the other one, you have artificial rubber. Right? On the other one, you have the artificial rubber. One is cis polyisoprene, the other one is trans polyisoprene. Right? Cis polyisoprene, and other one is trans polyisoprene. So this is the rubber isomer. right? This is the rubber polymer. This is the rubber polymer. This is the polymer of it, right? This is the polymer. So this group is attached to that side and that group is attached to that side. So this is the cis part, right? This is the cis. And the other one is trans, right? Yeah, and the other one is trans. If you take this one up and the hydrogen down, you have the trans. So the thing is, they cannot interconvert in between each other. The natural rubber cannot convert to artificial rubber. එහෙම වෙන්න බෑ, right? You can't rotate it and do it, make it into another one. එහෙම බෑ. Make එකක්, right? One is one, the other one is other. The one example is what you have in the bio book under lipids, trans and cis fatty acids. Those are two different things, right? You can't just rotate it and convert it into a trans or cis. Trans is one, cis is one, right? There are two different compounds. So that is what I told. Due to the pi bond, you cannot interconvert them. You cannot rotate them actually. You cannot rotate them. එකක් අනිත් එක තව එකක්, right? Right then. Next page. We move into enantiomers. Right. Enantiomers. Stereoisomers, which are mirror images of each other, are called enantiomers. Right? Stereoisomers, which are mirror images of each other, are called stereoisomers. Right? Stereoisomers mean enantiomers. For example, if you hold your hand to a mirror, right? You're going to hold your hand to the mirror. The nearest part will form near and the farthest part will form farther away, right? So like this. So this is the mirror image. This is the mirror image. So when you go to the mirror, you will see someone similar to you, but that is not you. This is not you. This is the other version of you. You raise your right hand and that guy raises his left hand. You go in front of a mirror and you stand and you raise your right hand, will you? He will raise his left hand. In his point of view, it is the left hand. Did you ever think about it? It's not you. It's someone else. From today onwards, I'm telling you, actually mirrors are working like this. Somebody is inside the mirror who is looking like you and acting like you. You can't break that concept. He is going to do the exact opposite of what you're doing. He's going to do the exact opposite of what you're doing. If you lift your right leg, he's going to lift his left leg. Right? If you lift your right leg, he's going to lift his left leg. Yeah, maybe it's another universe inside the mirror. It's another universe. Right? Universal reflection, you see. This is your other person in another universe. Maybe. Right? Who knows? So that is it. Right? This is it. So you cannot superimpose each other. See? You cannot superimpose one on each other. That is what's important. You cannot superimpose one on each other. So in the book, in the tute, I have given you one compound. Read that part. A compound having a carbon atom which is joined to 4 different groups shows enantiomerism. Enantiomerism. Such a carbon atom is called as an asymmetric or chiral carbon atom. Chiral carbon atom එකක් කියන්නේ any carbon atom that is joined to 4 different groups. So in this case, I have given bromine, fluorine කියන්නේ FR එකක් එන්නේ, right? Fluorine and then chlorine and then hydrogen. අර මොනවද අර මේ arrows මෙහෙම එකයි තියෙන්නේ. One is coming out of the book, the other one is going inside of the book. Don't worry. I got it. Right? You're going to have some sessions like that. Don't worry. One is going into the book, other one is going out of the book. You don't have to mark it like that in the exam. It doesn't matter. Right? Okay. Then people, this one's mirror image. Make a mirror image. Again, fluorine is going to form on the nearer side. Carbon is going to form here. Bromine is on the same place. and the hydrogen is on the other side, and the chlorine is going to form like this. So this is the mirror image of this one. Right? This is the mirror image of this one. That means this is a separate compound, that is a separate compound. The best way to identify this is take a selfie photo of you without mirroring it. මට මේක වෙලා තිනවා. When I take a selfie and I mirror it to the other direction, I look very ugly people. මට නිකන් බලන්න අපිරිය. It's like not me. When I mirror it. Actually, that is how other people see me. Maybe that's why that's the reason, right? So when that's how other people see me, it's very ugly people. Right? How I see myself in the mirror, that is what I'm familiar with. You guys see me on the screen, this face. That is what I see if I flip it. So what I see on my screen is not me actually. That is the altered version of me. I know this is hard to get inside your brain, but that's the thing. Make a mirror image එක තමයි මෙයා. Exact mirror image. It's not same. එකම එක නෙමෙයි ඔය තියෙන්නේ. හැබැයි mirror image එක. Did you understand? You will never be able to make this one equal to this one. You can't do that. You will never be able to. No matter if you rotate or do like this or do like this, you will never make it into this shape. Because you cannot overlap. Did you understand? You cannot overlap. It's a mara concept. It's like very nice concept. If you get into your head, you can think about in days. Like you can think about for days. Sitting on your sofa, looking at the night sky, you can think about it. You will never be able to overlap these two together. Never ever. Did you understand? Now don't take your selfie camera and take a photo and flip and see. Over කරන්න යන්න එපා. No, you have to take your sofa outside. That's the thing. You have to take your sofa outside. Hurry. So people, that's the theory. That's the theory behind this. It's just the opposite image. So what should be there is the chiral carbon. So this is the chiral carbon. Chiral carbon. This is the chiral carbon. That is the chiral carbon, right? That's the chiral carbon. It's the chiral carbon. Chiral carbon is a compound, is a carbon atom which is attached to 4 different groups. See, it is attached to 4 different groups. So in isomerism questions, they will say compound B does not show optical isomerism, does not show enantiomerism. ඔන්න ඔහොම එකක් කියන්න බලන්න, right? Does not show enantiomerism, does not show optical isomerism. Right. One more thing I wanted to highlight. Under enantiomers, the first sentence, stereoisomers, read carefully. Stereoisomers. ඒ කියන්නේ මොකද්ද? Stereoisomers කියන්නේ actually it's common for both enantiomers and diastereomers. Both of them, right? Stereoisomers which are mirror images of each other are called enantiomers. Are called enantiomers. They are called optical isomers. Highlight that whole thing. Highlight that whole thing. Right. Under that, people write another sentence wherever you have space. Wherever you have space, right there, with a red pen or whatever it is, හොඳ අර strict point එකක් දාගන්න. Stereoisomers which are not mirror images of each other. Stereoisomers which are not mirror images of each other are diastereomers. Stereoisomers which are not mirror images of each other are diastereomers. Highlight that point. Highlight that point. Highlight that point. Stereoisomers which are not mirror images of each other are diastereomers. Highlight that point. Right? Stereoisomers which are not mirror images of each other are diastereomers. Right. I want to show you this is the MCQ which I got wrong. Wait. 2024 paper. It's a very historical paper. I like the paper so much. This is the this question, 40-second question. 40-second question. Second question. First statement. This compound and this compound are diastereomers of each other. That statement is correct. Stereoisomers which are not mirror images of each other. Stereoisomers which are not mirror images of each other are diastereomers. මම දැන් කියපු statement එකනේ. ඕක resource book එකේ කෙලින්ම දීලා දෙනවා, right? It is directly given in the resource book, right? Yeah, I also took the second answer. I took the second answer here. It's very logical, right? It's very logical. I took the second answer, but it's the first answer. I took the second one, but it is wrong. It's answer 1. It says, it explains the first statement. How? I researched on this actually, right? So people, these are diastereomers. These are diastereomers. This structure and this structure are diastereomers. And they say stereoisomers which are not mirror images of each other are diastereomers. Oh, we think this is a diastereomer and they are saying stereoisomers which are not mirror images of each other are diastereomers. And they want you to take answer number 1 for it. Right? They want you to take answer number 1 for it. It is very tricky. It is very tricky. It is very tricky for you to select in between answer 1 and 2. That's what I told. Even for me sometimes in the exam, right? 1 and 2. Right? මේ දෙක තෝරගන්න පට්ට අමාරුයි. This problem is there for people who score. උන් දන්නවනේ මොනවා හරි. උන් දන්න හින්දා වරද්දනවා, right? They know a lot of stuff. They know a lot of stuff, so they can argue. Right? They can argue. I also argued, and I got it wrong. If I didn't know it, if I didn't know any of that, if I didn't overthink, I would have got this correct. That's it. Sometimes knowing much will also put you in trouble. Right. Then people, yeah, that's it. Then read that part. One enantiomer rotates plane polarization. One enantiomer rotates the plane polarized light. Rotates plane polarized light. Rotates plane polarized light in one direction. ඒවට කියන levo rotatory කියලා. ඒවා වැඩක් නෑ. We don't need them. Levo rotatory අනිත් එක dextro rotatory. People, have you done microbiology? Have you done microbiology? Have you done microbiology? Biology, right? In biology you have microbiology. Have you done it? Everyone who are doing bio? Maths ungen නෙවෙයි හැවේ, right? Bio කරනවා. In microbiology, you will see under preparation of culture media, you will say, you will have dextrose. What is dextrose? It's the glucose's optical isomer. Glucose optical isomer එක තමයි dextrose. Right? Dextrose කියන්නේ මේ glucose එකේ අනිත් එක. ඒ කියන්නේ glucose එකේ අනිත් එක, right? Dextrose කියන්නේ ඒකට, right? They have different effects. So that's how you see. So same compound, the mirror image is different. So you see yourself in the mirror, that guy is different to you. He's not you. He might have different personality, even who knows? That mirror image of you might not be the same person. You two have different things, right? Your face is older. It's not you. You have been fooled. From childhood, you have been fooled. That is you. That is not you. You are very ugly people. What you see in the mirror is very beautiful. You're actually ugly. Everyone has that, right? Actually, your face is flipped. Other side. That's it, right? Accept it. Accept it, right? Put it inside your heart that you're ugly, right? Other people don't see the mirror image of you. Do you have that habit, like when you take photos with the front camera, do you have that habit of mirroring it? Do you have it? Some people have. I also have it. Right? Are flip karana camera එක flip කරනවා අපි. අර photo එක flip කරනවා. Why? Because it's different. Right? Some people do it. Yes, there you go. Some people do it. They are not familiar with their look. Why is that? It's the mirror image of them. It's the mirror image, right? Hari people. Isomerism make a theory part right? Then read this part. Compounds which rotate the plane polarized light are known as optically active compounds. When more than one chiral carbons are present, we can find how many optical isomers are there using the following equation. 2 to the power n. Right? You can apply 2 to the power n. This is the chiral carbons. Number of chiral carbons. The chance of asking this is maybe 5%. Number of chiral carbons. Number of chiral carbons. Number of chiral carbons. So 2 to the power n. If there are 2 chiral carbons, then 4 optical isomers possible. If there are 3 chiral carbons, then that means 2 to the power 3. 2 into 2 into 2. 2 into 2, 4 into 2, 8 possible. Right? Hurry, people. Hurry. Then you can have a break. You can have a break. 20 minutes break you can have. I will meet you at 9:30. At 9:30, we will do the remaining part, hydrogen bond formation. And then boiling point variation, which is very important. Boiling point variation, I'll teach you how to differentiate in between solids, how to differentiate in between liquids, and how to differentiate in between gases, and then how to differentiate between ionic compounds and then covalent compounds and everything. The whole syllabus, boiling point, I'm going to discuss here. Again, හැමදාම structure and bonding වල චුට්ටක් තියෙනවා, organic වල චුට්ටක් තියෙනවා, inorganic වල චුට්ටක් තියෙනවා, right? Yeah, you're going to differentiate in between those what you call metallic bond strength, right? In between solid sodium and magnesium, who has the higher melting point, boiling point, right? Boiling point and melting point, right? So everything I'm going to discuss under the boiling point variation, right? So I'm going to cancel the meeting now. Isomerism part is over, so I had to upload this to YouTube separately. I'm going to cancel this meeting and then I'm going to put it to only the revision students, right? Only the revision students I'm going to put. The boiling point variation and hydrogen bonds are forming. I'll put after 20 minutes. You have to join after 20 minutes. I'll start at around 9:30. At 9:20, I will put the link. Okay? Right.